Bismillahirrahmanirrahim. Today we will start on new lecture. The title is Design of Sewer for both separate and combined sewer. Uh, so let us start. In the previous lecture, we discussed some important topics, which is the estimation of the quantity of sewage, that how to estimate the quantity of sewage, the volume of wastewater that is produced by any population, and we also done the population forecasting, which is the important factor in the calculation of estimation of the quantity of sewage, and also an important factor in the design of sewerage system, sewer system. Then the wastewater flow patterns for 24 hours, which is also important for the population, for the estimation of the sewage and sewer system. Then also the variation and the sewage flow. I mean the peak factor within 1 day, within 1 week, and within 1 month. In this lecture, we will perform some. We will do some examples, some numericals on that how to design a sewer system for separate system and for combined system both. So the first example is if you have a residential area whose population density is 15,000 person per square kilometer, and the area of that population is this much, and the water consumption of that population is 400 liter per capita per day. You need to find the average and maximum sewage flow. The unit must be in meter cube per day. So simply you can see the population density, which is given, area is given, the average water consumption is also given. So from that these values, one can calculate the total population, which is the 15,000 per kilometer square, multiplied by the area and divided by 1000 square, which is the conversion of meter square into kilometer square, and this gives us 1800 persons. So the population of the selected city is 1800 persons. So the first, I think it is very simple in order to calculate the population of any area when the population density and area is given, and also the average water consumption is also given. Now the average sewage flow, it means that this area, which is almost 1800 person, produce how much sewage, means how much wastewater that produce by this community. So the number of person in this community is 1800 per person. Wastewater generation is 400. I think this is the average water consumption. So it means the 400 value as the water supply, and we want to calculate the wastewater consumption, wastewater generation from of that city, which is the 75 to 80% of the water supply. So therefore the 80 divided by 100 is means 0.8 is already multiplied with the water supply, which is 400. So the number is 576,000 liter per day. When you convert it into meter cube, so it will give 576 cubic meter per day. So this is just the volume of water, the volume of wastewater that is produced by 1800 person per day. Now this is the average flow, and we want the peak factor to calculate, which is required in the design of any type of sewer for the estimated sewage quantity. So the peak factor, suppose we call the peak factor as m, and the formula as 1 plus 14 divided by 4 and plus under root p, where p is an 1000, p is the population and 1000. If you see, the population is given is 1800. When you take it in 1000, so you just see 1.8. So the peak factor is 3.62. Just multiply this factor with the average flow, and you can see the peak maximum sewage flow that can be produced by this much this number of peoples. The next example is the size and slope of a sanitary sewer. There are two types of sewer. The first one is the sanitary sewer. The second one is the combined sewer. Combined sewer means the sewer that are designed for both the sanitary purpose and for the storm sewer also. So in this example, calculate the size of a sanitary truck sewer serving a population. Trunk sewer, it is a trunk sewer, TRUNK, trunk sewer, which is the population of 0.4 million. Suppose any area whose population is 0.4 million and use the peak flow as 2.3. Calculate the sanitary sewer for this much people. Water consumption is also estimated. So this is the trunk sewer whose serving population is 0.4 million. For 0.4 million people, a sewer system is already designed, and we want the dia of that trunk sewer. The peak factor is 2.3. The water consumption is also given, which is the 300 LPCD, means the population of this city is 300 liter per capita per day. The pipe is the type of pipe is RCC pipe, reinforced concrete pipe, and there is also some water from the water table to infiltrate into the sewer, which is called the infiltration, and we take the value as 10% of the average sewage flow. So you just want to find out the dia of the trunk sewer. So how can we solve this problem? By just first we want the water supply to that community, as the population is also given and the per capita demand is given. The population is 0.4 million, the per capita demand is 300. Just million convert to the number of people, 4.4 million. So convert into a number which is 120,000 meter cube per day, or divide by 24 multiplied by 3600, convert into second. The day is converted into second, which is 1.388 meter cube per second. So the water supply is to this community, to 0.4 population, is 1.388 meter cube per second is the water supply value. So then the dry weather flow, average sewage flow, which is 1.388 multiplied by 80 divided by 100, is 1.11 meter cube per second. What does it mean? It is the wastewater that is generated by this much population, which is the water supply is 1.388, and the wastewater that is generated by this much persons per second is 1.11. Simply multiply the 0.8 with the water supply, which is 96,000 meter cube per day. This is the average flow. Just take the peak factor, which is 2.3 given in the problem. So the peak factor is 2.3 multiplied by the wastewater that is generated, average wastewater. When we multiply with the peak factor, so we can see the peak sewage flow per day is 220800 meter cube per day. And the infiltration, which is given, is 10. Just multiply with divide by 100, which is 0.1, and give as the waste. You can see the infiltration is 10% of the average sewage flow. So 10% of the average sewage flow, the average sewage flow is 96,000, and 10% of this is 9600 meter cube per day. So the design of the flow is the peak flow plus the infiltration flow. Means the peak flow is you can just multiply the average flow multiplied by the peak factor, which is the peak flow, and plus infiltration is 9600, which is the 230,400 meter cube per day, which is 2.67 meter cube per second. So for this design flow, you can just find out the dia of the sewer. As we know that Q is equal to AV, and the discharge is 230,400 meter cube per day, which is given, multiplied by 1 divided by 24. It means that the day is converted into second, which is 2.67. Is equal to area into velocity. Area, the velocity is also given, which is 0.6, and area is unknown, so area is equal to 4.45 meter square. So the diameter is 2.38 meter. You can just calculate it. The area is equal to pi d square divided by 4, and just keep d as this on this side, and the fixed values the converted into the other side. So the diameter is 2.38 meter. So now you can also see the velocity from this. You can check the velocity from this Manningh equation. V is equal to 1 by n r divided by 2 by r to the power 2 by 3 s to the power 1 by 2, which is 0.6. So velocity is already given 0.6. So you can calculate the slope from this calculation, which is 0.000115 millimeter. So the dia of the trunk sewer is 2.38 meter, and the slope of that trunk sewer is 0.000115 millimeter, which is already calculated for the population of 0.4 million. This now the sewage flow for stormwater. Stormwater is when we want to calculate the dia of when we want to design the combined sewer. So we must calculate the amount of stormwater that are generated after the sudden rainfall. So the first method is the rational formula, which is simply K is equal to CIA, which is already discussed in the previous lecture. The second one is the time of concentration method. So the time of concentration method is defined as the flow time from the most remote point in the discharge area to the point under consideration. The time of concentration consists of two part, which is inlet or outlet flow time, the time taken by the water to flow over land from the critical point up to the point where it enters the drain. So this is the typical definition of time of concentration when the rainfall occur, and when it produces the runoff, and from from a critical point. Suppose we want to calculate the time that the runoff generated and reaches to the a specific drain. So that time is called the time of concentration. A number of factors like rainfall intensity, surface slope and roughness, flow distance, infiltration capacity, and depression storage affects the flow inlet time. The formula that is used for the time of concentration is the first method is 0.8885 L cube divided by H into 0.385, where Ti is the inlet time in hours, which is the time of concentration, length of the overflow, and H is the total fall of the level from the critical points to the mouth of the drain in meters. The second one is the channel flow time. So the time taken by the water to flow in the drain channel from the mouth to the considered point. Suppose in this type we just want to we just select an open area and we select the two different points. Suppose the upper point is the critical point and the lower is suppose is the drain. So the time that is required to that is required for any runoff produced from any rainfall activity, when the time takes from the critical points to the drain, so it is called the time of concentration. The second is also the same, but the selection of an open area, we just want to select the a closed drain, a closed channel, an open channel, but we just select a channel, and we want to select two different points within the channel, and when the time taken the time taken by the runoff produced by the rainfall from the first point to the second point is called the time of concentration by the definition of the second method. The TF is the length of the drain divided by the velocity of the drain, which you can also see the velocity is equal to distance divided by time, the displacement divided by time. This is the same definition. The time is so the time is equal to the length divided by velocity. That is the same definition. So the time of concentration is equal to TE is equal to TIF plus TF. So the time of concentration for the both, you can just add both of them. The example is a watershed to contribute in urban storm drainage as 50 hectare, of which 30 hectare having C value is 0.36 with 7% slope, and 20 hectare of 0.5 with 3% slope. The length of runoff is 720 meter. Calculate the runoff if the rainfall intensity is 15 centimeter per hour. Velocity of the flow is 1.2 meter per second. You can see the area is given, which is 50 hectare, of which 30 hectare having C is 0.36. Out of 50, the 30 hectare area has the C value of 0.36, while the remaining 20 hectare area having the C value is 0.5. The I value is given for both is 15 centimeter per hour. So the required is the peak discharge that is produced by the runoff by the rainfall activity, which is the 15 centimeter per hour on this two types of area, which is the total 50 hectare area, but the 30 hectare has the C value of 0.36. This means that the surface of the area is another type, and the 20 hectare area whose the C value is 0.5 as of another type of area, surface area. So we just want to calculate one C value from these different type of C's. The C value is 30 multiplied by 0.36 divided by the total area plus the 20 which is the part of area multiplied by 0.5, which is given, the C value is given, divided by the total area is equal to 0.416. So this 0.416 is the cumulative C value for the whole 50 hectare area. So the time of concentration is equal to the length of runoff divided by the velocity. So length is already given, which is 720, and velocity is 1.2 multiplied by 60. 1.2 is the you can see the velocity of the flow is 1.2 meter per second. So just convert it into the minute. 1.2 multiplied by 60 as the conversion to minute, which is 10 minute. So the rational, then use the rational formula, which is K is equal to CIA. So you can see the Q is equal to 8.65 meter cube per second. Similarly, the third method is the stormwater sewage calculation is by the Soil Conservation Services, which is the SCS method. This SCS method is based on the curve number, which is called the CN number. So the CN number is basically the runoff coefficient, and this value is depend on the type of soil. Basically, there are four hydrological soil groups, which are the A, B, C, and D. The group A is the lowest runoff potential. The group A CN number is consists of deep well of excessively drained sand or gravels with a very little clay and silt, and you can see you just read all of them, group C, B, D, and A. Now the example is a residential urban area has the following properties of different land use: roof 25%, asphalt pavement is 14%, concrete sidewalk is 5%, gravel driveways 7%, grassy lawns and average soil and a lateral slope 49%. Compute an average runoff coefficient using the values. So I just create a table from it. You can see the type of surfaces as the roof, asphalt pavement, concrete sidewall, gravels, grassy lawns. So the percentage of the total area, the roof is 25%, asphalt is 14%, concrete sidewall is 5%, and so the total area is 100%. The C value is already given, which is 0.75 to 0.95, 0.85 to 0.9, and many more. You can just take the average of all the C with respect to the area. You can just get the value, which is 0.45, 0.25. The product is which is given is 0.175. 0.17. How can you get this value? Just multiply 0.7 to the 0.25. 25% means 0.25, so just multiply 0.25 to the 0.7, which is 1.75, and multiply 0.25 to 0.95, which is 0.2375. Similarly, you can do all the values one by one. So the average value will be the C value, which is 0.45125. These are the steps or stages for design of sewer. You can see there are many steps. The first one is the preliminary investigation. If you want to construct a sewer in any area, if you want to line a sewer in any area, so you need some important steps to be followed up from the initial point to the final stage. It includes if the map of area is not already available, the first step is to carry out the survey to draw the map of the project area. You can just if you have not a detailed map, so you can just visit the area and prepare a map of that area. Different detail are marked on the map, like street, railway lines, street locations, and underground utilities like gas, water mains, etc. You can just mention all these things on your map. Establish the benchmark throughout the area and make down profiles. You can also create a benchmark for your survey, and also provide the mean sea level value or to that benchmark. exact value. Also, the soil conditions should be investigated for the type of stratum, location of water table. The location of water table is very important, because if the water table is very high, so it means the infiltration of the water table will infiltrate into the sewers, which increase the stage of the water within the sewers. Also, the presence of any underground rocks, it will increase the cost of excavation. Collection of rainfall data, study of the natural slope area, and selection of the suitable disposal point. The second one is the design concentration, formulation of the design criteria, which so the first one is the sanitary sewer, which is the peak flow plus the overflow plus infiltration plus industrial flow minus the exfiltration means the water that may remove that may comes out of the sewers from the giants. Sewer are designed on the basis of the open channel flow. Also, the velocity will be calculated using the Manning formula. The minimum velocity, which is also called the self-cleansing velocity, must be maintained to avoid the suspended solid, to avoid the deposition of the suspended solids, which produce the methane gas, CH4 gas, which is the mainly responsible of the corrosion of the sewer. So the sanitary sewer minimum velocity must be 0.6 meter per second. The storm sewer must be 1 meter per second, and the partially combined is 0.7 meter per second. The design velocity is a limit on higher velocity to imposed due to abrasive character of solids and wastewater, which is called the higher velocity. Other reason is that there will be higher slope of sewer and result more excavation. When there is a higher slope, means the velocity is very high. So if we use the higher velocity, it means you will give the higher slope to the sewer, and higher slope means the more excavation will be needed for that sewer. The maximum velocity depends on the nature of material from which sewer has to be constructed. In likely area, we have to provide more slope due to natural slopes. Maximum velocity must be less than 2.4 meter. This is obvious. I think this is. So the non-scouring velocity is 0.6 to 1.2 for earthen channel. Brick line is 1.5 to 2.4, and many more. Generally, 2.4 meter per second is used for sewers. The preparation of the number 4 step is the preparation of the drying and bill of quantities. So the minimum size of the sewer is 225 millimeter. Is taken as the minimum size by WASA, water and sanitation. So the minimum cover is taken as 1 meter. Minimum cover means the soil that are above on the sewer is called the minimum cover, which is 1 meter, at least 1 meter. Preparation of the drying and bill of quantities. Typical drying includes of the sewer points, manholes, disposal stations, sewer profiles, and all sections. This is the problem which is already discussed. If you have the population, so convert it into the sewage flow by just multiply it to 0.7 and 0.8, and then multiply the average value with peak factor in order to calculate the dia of a sewer. You must find out the peak factor, peak discharge. So then the infiltration is 0.05 to 0.1 of Q average 10% of you can see in the previous example 10% is the infiltration or infiltration value. So you can take zero point 0.1 of Q average is the Q infiltration. So the design flow is the Q peak plus the Q industrial plus the Q infiltration. You can see this is the example. This in this example is basically when the sewer pipe is not flowing full. If the is we already discussed this example in the previous lecture, as the dia is given as 915 millimeter, the slope is 0.003 and n is 0.013. The full velocity is given, so Q is equal to AB. You can just use the two charts which is used for the partial flow, the partial flow graph, which is two different lines of the first one is the velocity line, the second one is the discharge line, and you can calculate easily the ratios of velocity, discharge, and dia of each pipe, where small d is the basically the depth of water within the sewer. Then the sewer construction. Sewer construction means the first one is the excavation for sewer, which is basically the 1.5 of dia 1.5 multiplied by dia of the pipe plus 300 millimeter. This will be the width of excavation of trenches for a specific sewer. Then the line in joints of the pipes, backfilling, manual backfilling up to 0.75 meter. Backfilling means that the earth that cover the sewer pipes, and construction of appurtenance. Appurtenance is basically the supporting items that are needed for any type of sewer. Then the strength of the RCC pipe is very easy, I think. And next one is the sewer bedding. You can see sewer bedding. The sides of the earth must be compacted in order to carry a heavy load, which is basically on the top of the sewer. And then the test for leakages, water tests, and sewer testing for straightness. These are just theory. You can see if you have any question in this, just text me on WhatsApp or email or on my email, and we will discuss inshallah one by one.